Hello everyone, it's August 16th. Alright, let's get to it. Maximum number of points with cost. You're given m by n integer matrix points. Starting with 0 point, you want to maximize the number of points you can get from the matrix. To gain points, you must pick one cell in each row. Picking the cell at coordinates RC will add that to your score. However, you will lose points if you pick a cell too far from the cell that you picked in the previous row. For every 2 adjacent rows, R and R plus 1, picking cells at coordinates RC1 and R will subtract C1 minus C2 from your score, or to the maximum number of points you can achieve. So if I pick this as 3, if I pick this, I'll get the full score. But if I pick this, I'll plus 5 and minus 2. So basically, this is 11 minus 1 minus 2 is 9. Okay. Dear me, 10 to the 5th. Huh. Some sort of DP, most likely. Let's see. Yeah, we can just like brute force. Like if the first row I pick a certain one, and the second row. Wait, hold on. If I have some DP system set up, right? If I have like everything set up, and I can say if I pick this, what's the maximum, right? What's the maximum ending at here? What's the maximum ending at here? And what's the maximum ending in here? So if I know that, then I say if I pick this, then I do the maximum ending at here. I'll just add 3. The maximum ending here is going to be adding 3 minus 1, adding 3 minus 2. Right? And I go here, then I need to check again. It'd be interesting. So for each one, I need to go through the entire row. Can we like know it faster? I mean, we don't have to go through them all because you have to remove, right? Reduce. So basically, like this is the first row is this score, right? So we start from here, and I say, okay, if this is going to be 2, right? If this is going to minus 1, this is minus 2. But what if we have something really big down the line? So for this, the score is different. For each one, the score is different. Yeah, that's OM n times n. I think that will definitely that feels like we are going to time out. Because each one you have to go through this one you have to go through all this one you have to go through. So every one you have to go through everything. And the only difference is the cost will be different. Can we like pick it out faster? Or you pick the largest? Let's say we sort every row, okay? We sort every row from large to small with their positions. And then we can compute if we pick the largest, what the result will be. But then what? It's basically like for each one, what's the best for it? Right? What is the best for it? And everyone have a different value. That's the thing. That's why it's kind of difficult. Everyone has a different value. Well, if n is very small, then it'll be fine. But if n is big, maybe that's the trick. But I mean, n is big. It could be like square root of 10 to the fifth, and it will still be too big. It's like 3,000 something, right? 300. What's 10 to the fifth? 316. So it could be a big one, but if it's big, what do? You have to go through every single one, then you just add on to it. Yeah, I don't really think that's the right way. There gotta be an easier one. So for each one, right? Just have a curve. So you're saying we have, let's say, a sorted array. Okay. Then each one dynamically need to deduct some value. And the question is, which one will be the maximum after you do the deduction? Now, just give you an array, right? And then each position, each value will have a different amount to get deducted. Can we have a faster way to find out which one will remain the maximum after we do the deduction? After we do the deduction. But you'll have to sort them. Yeah, I don't know, it's three levels. I feel it's gonna time out. And other than that, I really have no idea. Okay, let's see. What type of topic? It's DP. Try using DP. Alright, so this is a different type of DP. Is the maximum number of points you can have if points is the most recent cell you picked. The one I say is DP this is most recent cell I pick. Is that a hint that it will not time out? I don't know. Because you have a really long, like only 2 lines. And for this one, each one you have to go through the whole thing. This you have to go through the whole thing. This you have to go through the whole thing. Right, every single one. Like O(n) squared. And n can be huge. I feel like it's gonna time out, but that's what it means, right? I mean, we can try. I mean, it's not gonna be difficult to write, but I am really not sure. I feel this is gonna time out, but it doesn't hurt to try. We'll give it a shot. So I'm just gonna use the points by itself. So I can just say for int I equal to 1 smaller than points dot length. And let's probably do points dot length. Alright, this is I. Alright, this is J. We'll go through every single one. And for each one, I have to go through them again. Alright, we'll go through them again. And okay. Right. So current max are equal to maximum current max and points ij plus points I minus 1 k minus math.abs j minus k. Right, so after doing this, we get a current max. Now we just say points ij equal to current max. Right, and now we go for the next one, go for the next one, and then at the end, int res equal to 0. Int p of points n minus 1. No, m minus 1, the last row. Yeah, this will be right, but it's gonna time out. I still believe this will time out. I still believe so. It will be correct, but I feel it will time out. Unless we can figure out a way to make, don't go through all of them. I mean, yes, we probably can, but again, we don't know, because we can have some really big value down the line that we have, like some negative happens, but we still have to keep going. And if you sorted it, it's all right. We can try, and if it times out, and we think about it again. Timeout. Okay, it's not timeout, but it's a different issue. Gordy. Oh. Okay, it's the long thing. Oh my goodness. Okay, that's fine. That's fine. We can say long dp. I was not intended to do that. Okay, for int j equal to 0, j smaller than n, j plus plus. We can say dpj equal to points 0 j. Okay, and then long temp then we don't need to do that. Temp j go to temp j. This can be dp this plus long points. Actually no, that should be points and this is gonna be dp. Just dpk. Right, the points, the current point, right, the current point, plus previous. And after we're done, and everybody's positive, right? Yeah, so I probably can do this one here. Oh, long. Temp. Oh, I already have temp j, and then we say res equal to math.maximum res and temp j. Okay, something like that. Yep, timeout. Maybe we can game the system, you know? I feel like we can game the system. So when it's super long, then what do? When it's a super like fat and then fat, yeah, if it's a super fat one, I can, depending on the distribution of, right, depending on distribution. So maybe I can sort. But still, that's not a generic solution. If we can, you know, all right, maybe we can do this. But you have to, if you want to find a maximum. So as you go through, you get a maximum. So if the deviation is larger than that, then you just quit. So we can do yeah, if the deviation is, so okay, so maybe we can say max row max okay, so we have a row max. So for h1, k smaller and dot abs j minus k is smaller than row max. Because if it's bigger, then what we're trying to say is it's going to be negative, right? You're not getting anything. But I mean, what we do is, oh, it's actually not. It's the dpk. It's dpk. Hold on. Int p. I think it's dp. Oh, it's gonna be a long. Right. So we get a row max. And then we say if, because we are adding through all of them, right? But if the distance is bigger than what they can do, then it will definitely give me a negative value. And if it gives me a negative value, that means there's no point keep going, right? There's no point keep going, which means we shall start from something that's, because we start from J, right? We start from J. So the range shall be, they will still give me a positive value out of everything. So how do we manipulate this? Because I have a current J, right? I have current J. So I know the row max. So J minus row max, right? Whatever the J is, we just count left, row max. So we can say max.maximum 0 or J minus row max. Right, so we'll start from here. Ah, boy. Okay. And then K shall smaller. I think smaller equal to max.minimum J plus row max. Say J plus row max. So it'll be N J plus row max plus 1. So I can do a smaller than. Alright. If the row max is 50, right? So if J plus 50 is 50 something, and then you'll still maintain positive. So we'll do that, and then temp J is equal to this. So okay, so we add this. Let's see, if with this little trick, let's make sure that the previous one is correct. Previous one is correct. And we'll try with this. See if we pass this one. So we have a row max, so we can restrict. So yeah, so we restrict. This might work. This might work. (1937). Basic DP, where DP I J is the max points earned when points I J is selected. However, this will result in OMN squared times n runtime, and it will time out if points is a very fat matrix. To reduce the amount of check, right? We first obtain the max value for dp I-1, right? Then for the current, then for points I, we only visit the j's that do not result in a negative penalty. Do not result in a distance penalty larger than the max of dp I minus 1. This can shrink the amount of check needed, but still not foolproof, because I can see scenarios where this can fail. Still fail. But we will try this, and yeah, who knows? Maybe this will work. All right, let's try this, see if it works. Yep, it does. It does work, but it's not. It's definitely not what we want. Yeah, it works, but it does not. It's not what we want. Okay, now let's check. What are the tricks? Okay, what are the tricks to make it faster with DP? So solution 1, solution 2. Okay, let's see. What is your trick? This is OMN. Okay, so it's a much better DP. Okay, how do you do the DP? Best time to buy and sell stock. I know this one. I've done this many times. It's similar. I didn't see the similarity. Yes. 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 Okay. Yes, this is what we do. Well, with a little bit ingenuity, you do pass, but yeah, this is not the right way to do it. Okay, we have two auxiliary arrays, left max and right max, to store the maximum possible contributions from the left and right, respectively. This allows us to simply compare these two pre-computed values to determine the best score for each. To construct left max, for each subsequent, compute left max I as the maximum of previous row and left max I minus 1 minus 1. What? The maximum of previous row I and the left max I minus 1. So we say in left max. Okay, let's see. Previous row, 2 indices to consider. Previous row and max I minus 1. Here's the okay. Left max I minus 1 contains the maximum points achievable. The maximum, wait, hold on, what? The maximum points achievable, including everything. It's like a prefix max. Okay, maximum, okay, if that's the maximum achievable of everybody to the left, well, take the maximum out of 2 choices. Take the maximum point from left, shift it by 1, or take the point directly with no penalty. So for this point, I either take the max from previous, but we need to shift by 1, so into minus 1, or we take this. This is a very interesting idea. I still, hold on, I need to think about this one more time. So we're saying, that's actually the DP, right? That's actually the DP. What we're saying is, I have left max value will get all the max available, which means if you're picking at this point, what is the maximum you can get? Okay, which considers all the previous. Like if you pick the previous, we have the minus bunch in here. So everything, the maximum, picking whatever in the previous one, and this is the best one here. Okay, so we are considering everything. And now for the next one, right? For the next one, so if I have a big value, minus something will come here. Then this one minus something will come here, right? And it works because as we move forward, whatever is the max already will continue to be the max. Because you just constantly remove one, remove one, remove one. So whatever is the max to the left, doesn't really matter. You even have to think about all that. You just think, okay, at left max I minus 1. Okay, left max I minus 1 will record the max value achievable. If I pick from in the previous row from 0 to I minus 1, whatever I pick, I just say that is the maximum. Okay, then for the next value, if we want to keep this, then I either take no penalty, or I take whatever is the max previously, and I take a penalty, just minus 1. And with that, when you do the new one, you can just refer to, so you get a left max, you get a right max, and then you pick the bigger of the two. You are kidding me. Huh. Wow. Left max and a right max. Optimized? What do you mean by optimized? Ah, I see. You get a left max. And you get a right max, and then you can update it along the way. Yeah, it's actually, wow. Yeah, I think there's actually two DP in this one. That's why it's tough. This is the official solution. It uses two auxiliary array, left max and right max, to find the max points achievable. Right? Max points achievable from the previous row, right? From the previous row in range 0 to I, or I to n. So essentially, this is a second DP, right? Because there we have the following relationship: left max I equal to maximum left max I minus 1 or dp I. Previous row, pre-row I. Yeah, we're saying that for the current position, right, the max value we can achieve is either with no penalty, take the previous row, right, to take pre-row I, or with a penalty, to use left max I minus 1. Same applies to right max. This solution runs in OMN. Very smart. Left max and right max. Okay, so if I want to do this, okay, then what? Then we have to say long dp shoot. Yeah, I don't like I. This should be J. Okay. Now, 1. Temp. So as the previous, so we need 2 arrays, but we can do create left max directly on temp for int j equal to 1, j smaller than n, j plus plus. Okay, and what we want to do is have dp temp. Okay, so temp 0 shall equal to dp0. Okay. So temp j shall equal to math.maximum either dpj with no penalty or temp j minus 1 minus 1. Okay. Now create write max and update temp directly for int, because each one is a left, will have a left max. Right max is going to be wait, how do you do it in one shot? Oh, you need a running max. Oh, yeah, that's a smart. Long current write max. Current RM. Actually, we can call it. That's fine. J equal to n minus 1. J logic is 0. J minus minus. Okay. And we have the current write max, but I need to update the current one first, and then I update the new current max, right? So we can say temp j shall equal to, we pick max of the two, if this or what's the current is the previous, right? So we can say current write max shall equal to math.maximum dp, right? dpj, so either use that or we use current rm minus 1. So we get a current max, and then temp j shall equal to math.maximum temp j with the current write max. And then we move on to the next one. Current write max is this, so I do temp j or this one minus 1. Yeah. Okay, so now we go through the whole thing. Then we need. No, we don't need anything. We go through the temp j, right? We'll go through the temp j. Temp j is the maximum value, and then we can say res equal to math.max res and temp j. And once we're done, we just return res. Oopsie doozy. That is not right. Huh. Oh, my bad. I forgot to add points I and j. Oversight. Even adding points interesting. It's still not right. Let's see. Do we have to long this thing? No. What went wrong? Oh, I know why. I did not update. So after we go through, dp shall equal to temp. Like multiple things are wrong with this. There we go. Okay. Yep. That was also an oversight, which I did not have earlier. Res or DPJ? Hey, should run this. 1, 2, 3, 4, 5, 6, 7, 8. Oh Lord, I think it's pending. We are not going to let it depend. We will just submit it. There we go. This is how it's supposed to be. Good question. Very good question. Tough. I feel like it's tough. Yeah. All right, that will be it. We're done with today. I'll see you guys tomorrow. Adios.